Okay, inverse trigonometric function. So we're going to look at, we've talked about inverses before. What's an inverse? It's not the reciprocal. What is it? It's a reflection over the line y equals x. So that means that all the x values and y values switch. Okay. So when we're talking about inverse trig functions, that means that when we do a trig function, that we could say, if we said the sine of theta equals its opposite over hypotenuse, right? Okay. So where theta is our x, and this would be our y, right? Okay. So then we'd be switching them when we're doing inverses. So when we do inverses, we would say the inverse sine of y is equal to x. So we're switching those things. We're switching the angle and the ratio that we get. Right? So something that we've done before. Right? Now the only thing is that we're talking about functions, so some things end up changing. And part of that is that there are restrictions upon sine, cosine, and tangent for the inverse functions. So for instance, for sine, okay, the inverse sine has a restricted area from negative pi over 2 to pi over 2. The reason is because if we kept going, what would happen? Let's think about it for a second. Let's think about the graph, right? The graph of sine looks like this, right? And so on, doesn't it? Okay. If I did the reflection of that over the line y equals x, if I switched x and y, then this graph would look like this. Oops. Right. Now, is that a function? Okay. It would look like this. And that's not a function, is it? So what has to happen is we have to restrict the values then so that it is a function. So for sine then, we restrict the values from here to here. Oops. So from, what were these? These were negative 1 to 1, right? Okay, this is negative 1 to 1. But what it does then also is that when we turn it back the other way, that restriction then is from negative pi over 2 to pi over 2. So when we're talking about the inverse sine function, we're talking about a region that is between negative pi over 2 and pi over 2. So any answer you get for the inverse sine has to be between negative pi over 2 and pi over 2. So if I was going to do the inverse sine of 1/2, okay, that would be pi over 6, right? Because the sine of pi over 6 is 1/2. Okay? But if I do a negative angle, or a negative number, like negative square root of 3 over 2, okay, inverse sine of negative square root of 3 over 2, then that's got to be at negative pi over 3. Because this answer has to be between negative pi over 2 and pi over 2. Here's, right down here would be negative square root of 3 over 2. And so that would have to be between negative pi over 2 and pi over 2 if it's not between there. So take out look at your unit circle, and we're going to look at where we look at for the negatives and the positives as far as angles. Now, in some of the math, when you go higher with your math in college and like that, you might see they call it arc sine also. All right. Now, so for sine, we're from negative pi over 2 to pi over 2. Where's negative pi over 2 at on the unit circle? What angle is it coterminal with? 3 pi over 2. All right. So here's the thing that we have to think about. These angles here, okay, that this is the same as negative pi over 2. This is the same as negative pi over 3, negative pi over 4, negative pi over 6. And so when we're talking about sine, we are talking about the angles from here. Oh, I won't do what I wanted to do. Oh, man, I was hoping it would. Let me do that. So when we're talking about sine, we're talking about here. From negative pi over 2 to pi over 2. So if they ask me to find the inverse sine of some angle, my answer has to be from here to here. So it's the right side of the unit circle. Okay, so you can think of it either that way. Right side of the unit circle. The fourth quadrant, then, we're using negative angles, not the positive. Because remember, I can label this unit circle any way I want, can't I? I could label it with all negative angles. Okay? This could be negative pi here. This could be negative 3 pi over 2. Okay? It could be positive or negative. So you have to keep that in mind, that sine, the inverse sine, has a restricted area from negative pi over 2 to pi over 2. And if you look at your calculator, if we graph it, second sine of x, and hit zoom. Let's see, check my mode first because I want radians. Okay. And zoom 7. And here's the graph of it. Okay. The graph only goes from negative pi over 2 over here to pi over 2. It just doesn't keep going. Okay. So inverse sine of v is a unique number u in the interval from negative pi over 2 to pi over 2. So if sine of u is equal to v, then the inverse sine of v is equal to u. So we just switch the independent and dependent values. Cosine. Okay. Inverse cosine. Inverse cosine is between 0 and pi. So when we're dealing with inverse cosine, then we're talking about the upper half of the circle, where I have both positive and negative values. Now, the reason we don't use 0 to pi with sine is because the upper half of the unit circle is all positive values for sine, so that doesn't incorporate the positive and the negative. Those positive and negative values have to be together. And if we did the top half of the unit circle for sine, we wouldn't have that case. So for cosine, we're going to be doing an interval from 0 to pi. Right? So you're going to be, if you haven't written those down yet, you're going to want to write those down too, those restricted areas. Now the other thing is that we have to remember two things then. That where it says cosine of u equals v, all right, we know that in this situation, u is all real numbers for the domain, right? Okay. The range here is from, I'll use this, negative 1 to 1. Okay, that's the range for this one. Okay. So now then, when we're here for cosine or for sine, when we're doing inverse cosine, then the domain here is from negative 1 to 1. And then the range, okay, my y values then are going to be from 0 to pi. Where with sine, the domain for inverse sine is negative 1 to 1. And the range would be from negative pi over 2 to pi over 2. Now we said this domain here is all real numbers, but if I switch them, I don't have a function anymore. So that's why we have to restrict that. Tangent. Tangent is, all right, here's our tangent function. Now if we think about tangent, as far as the domain for tangent then, I have some of it in here. The domain for tangent, we said that x could not equal, what was it? Pi over 2 plus pi n, right? And the range here was all real numbers. So for the inverse tangent, for inverse tangent, then our domain is going to be all real numbers. And that's okay because we still have, if we take this graph and we do the inverse of it, then it's just going to go this way. Okay? All right? Which is fine. We can still have all real numbers for the domain, but the range then is going to be between negative pi over 2 and pi over 2. But notice, here they use parentheses instead of brackets. Why? Right, because for tangent it doesn't include them, right? Because at pi over 2 and negative pi over 2, what is tangent? Undefined. Okay, so it's undefined, so there's no values there. So we use the parentheses there. Okay, all right. So our inverse sine, we're looking at the right-hand side of our unit circle from negative pi over 2 to pi over 2. Cosine, we're looking at the top from 0 to pi. And tangent, we're looking at the right side from negative pi over 2 to pi over 2 also. All right, so we're trying to find the inverse sine of square root of 3 over 2. That means they give us the ratio, we're trying to find the angle. All right? And like I said, unless they tell us otherwise, we're in radians. Okay? So when does sine equal positive square root of 3 over 2 on the right-hand side of the graph? Okay, at pi over 3. So your answer should be pi over 3. Okay. Right. Inverse sine of negative 1. From negative pi over 2 to pi over 2, when does sine equal negative 1? And this is where, when they're negative, is where the biggest mistakes are made, because people will answer 3 pi over 2, but 3 pi over 2 is not between negative pi over 2 and pi over 2. So instead of 3 pi over 2, I'm going to say it's negative pi over 2. Okay. Inverse cosine. The range for inverse cosine is between 0 and pi. The domain is between negative 1 and 1. All right, so when does cosine equal positive 1? Oh, I'm sorry, I went to 3. I'll hit 2, 4, and 6. I skipped 3. Okay. All right. When is cosine equal to positive 1? Okay, it's 0. So this is 0. From inverse cosine negative square root of 2 over 2. We're looking from 0 to pi. Okay. It's going to be in the second quadrant, and that would be at 3 pi over 4. Now, this one's different. 0.14 is not on my unit circle, is it? Okay, so how am I going to find that? Your calculator. Yep. Take out your calculator. Inverse cosine, 0.14. And we get 1.43. Are you in radians? That's because you're not in radians. You're in degrees. If I multiply this by 180 and divide by pi, I'll get 81 degrees. Okay? All right, make sure you're in the right mode. Okay? Now, if you get a number bigger than 3.14 here, okay, you know you did something wrong because the answer has to be between 0 and 3.14. Okay, 0 and pi. All right, so that's one way you can check them. Okay? All right, so you should have 1.43. Okay? All right, let's go to number 5 then. All right, we're going to do these, and then we're going to look at the other ones, the even ones. Okay? Number 5, inverse tangent. Inverse tangent is between negative pi over 2 and pi over 2. Okay, so when does tangent equal negative 1 on the right-hand side of the unit circle? Where at, Megan? Okay, but 7 pi over 4 is not between negative pi over 2 and pi over 2, is it? So what would it be instead of 7 pi over 4? No, it's you're at the right location, but you're calling it the wrong thing. It's going to be negative pi over 4. Okay? This is negative pi over 6. This is negative pi over 4, negative pi over 3, negative pi over 2, and so on. Okay? It's just I'm going to the right here instead of going to the left. Okay? So anything in the fourth quadrant for sine and tangent, all right, when we're doing inverse, has to be one of these negative values. Okay? So if it's at the location of 7 pi over 4, then my answer is going to be negative pi over 4. Okay? Now, negative 14, is that on our unit circle? No, it's not. So that we're going to have to type into our calculator. Type that in your calculator, and you get negative 1.499 or negative 1.5. Okay. Properties of inverse sine, cosine, and tangent. So these are composite functions. Remember working with composite functions? Okay. If I do f of f inverse, I should get what? X, because these are reflections over the line y equals x. So if I put them together, then I should actually get that line y equals x. So you'll notice that this says the inverse sine of u is equal to u. Or the sine of inverse sine of v is equal to v. Now, the only difference is that we have here and here. All right? We still have our restrictions that when I do the inverse sine of a value, I have to get an answer between negative pi over 2 and pi over 2. If I do the sine of an angle, then I need to get a number between negative 1 and 1. Same with cosine. If I do inverse cosine of cosine, all right, because I'm doing the inverse cosine of a ratio, I have to get a number between 0 and pi. If I do cosine of inverse cosine, then the inverse cosine represents an angle, and so the cosine of any angle must be between negative 1 and 1. Okay? Applies to tangent also. So you have to take into account the fact that if I do the sine or cosine of an angle, I have to have a number between negative 1 and 1. If I do the inverse sine of a ratio, I have to have an answer between negative pi over 2 and pi over 2. If I do the inverse cosine of a ratio, I have to have an answer between 0 and pi. Inverse tangent of a ratio between negative pi over 2 and pi over 2. So you have to think about, okay, what can I get when I do this? So let's look at number 2 here. All right, you guys writing all that down? All right, it's in your book too. So, all right, looking at number 2. Okay, that's supposed to be covered up. All right, so it says explain why inverse sine of pi over 4 equals pi over 4 is true, but inverse sine of the sine of 7 pi over 4 equals 7 pi over 4 is not true. Okay, and here's in general, the reason why is because 7 pi over 4 is not between negative pi over 2, negative pi over 2, and pi over 2. That is why that's not true. Okay? And so let's go actually do the problem. So if I actually look at the problem, okay, and here's what happens. If I do the inverse sine, the sine of pi over 4 is equal to square root of 2 over 2, right? Sine of pi over 4 equals square root of 2 over 2. So if I do the inverse sine of square root of 2 over 2, we get pi over 4. Now 7 pi over 4, the sine of 7 pi over 4 is negative square root of 2 over 2. Okay, right? We're in the 4th quadrant. Okay. At 7 pi over 4, sine equals negative square root of 2 over 2. But when I do the inverse sine of negative square root of 2 over 2, I have to have an answer between negative pi over 2 and pi over 2. And since 7 pi over 4 is not there, then it can't be 7 pi over 4. It's got to be negative pi over 4. Okay? So that's why that's not true. All right? And basically it's because 7 pi over 4 does not fall between negative pi over 2 and pi over 2. It's at that location on the unit circle, and it's coterminal to the answer we want, but it's not that same answer. Okay? Now you have to think about it graphically also. All right, number 4. Is to write the cosine sine inverse of v as an algebraic expression in v. Okay. And guess what we're going to use to do this? When you started learning about sines and cosines and tangents, what things were we using with working with them? A triangle, a right triangle. And so we're going to use a right triangle here. Okay? So we got to pull all of that, bring that back into your thinking. Okay? Sine of theta is equal to what? Opposite over hypotenuse. Okay? So we have a ratio here, inverse sine of v. So that means v is the opposite, and what's in the denominator there? 1 would be the hypotenuse. So we have a right triangle here, and here's my angle. We'll call this theta. All right, that the opposite side is v, and the hypotenuse is 1. All right, and that's because sine is equal to opposite over hypotenuse. Okay. So what's the adjacent side then of this right triangle? How do we find that third side of the right triangle? The Pythagorean theorem. Okay, so we have this unknown, we'll call that x. So x squared plus v squared equals 1 squared. So x squared is equal to 1 minus v squared, right? So what does x equal then? The square root of 1 minus v squared. Is it plus or minus? We are taking the square root, right? Okay, can it be plus or minus? We're talking about a distance, right? When's the last time distance was negative? Can you have a negative distance? No. Okay, so this is just a positive number. So then to find cosine of this angle, cosine is adjacent over hypotenuse. So that equals the square root of 1 minus v squared over 1. Or just the square root of 1 minus v squared. Okay, so I added one here, 4a. Find the sine of the inverse cosine of 1/2. So here's the right triangle that goes along with that, isn't it? We have a 30, 60, 90 right triangle. If cosine, so when is cosine equal positive 1/2, or inverse cosine? What's the inverse cosine of 1/2? What is it? Pi over 3, right? Okay, if you look at your unit circle, cosine equals 1/2 at pi over 3. And what's the sine then of pi over 3? Square root of 3 over 2. Okay? So let's think about a triangle then for a minute, like we did here. Okay? Cosine is adjacent over hypotenuse. Adjacent side is 1, hypotenuse is 2. If we use the Pythagorean theorem, we would get the square root of 3 for the opposite side. And then the sine from here would be the square root of 3 over 2. Okay? So we end up basically with saying the sine of pi over 3, sine of pi over 3 is square root of 3 over 2. And I could do it with a right triangle as well. So anytime this number here, okay, is not something on your unit circle, then you're going to have to make a right triangle and work with it from there. If it's on the unit circle, just use your unit circle. If it's not, then you're going to have to make a right triangle, like we're going to have to do here with tangent. Okay. Here it asks us to find the exact value of the sine of the inverse tangent of 1/2. Now, does tangent ever equal 1/2 on your unit circle? No, it's not. Never equal to 1/2. Okay, so that means I got to make a triangle. And here's my triangle. Okay, tangent is opposite over adjacent, so I make my angle. Tangent's opposite adjacent, so tangent would be 1 over 2. Use the Pythagorean theorem. 1 squared plus 2 squared equals 5. So the hypotenuse is the square root of 5. So they want us to find the sine of the inverse tangent of 1/2. I draw the triangle that shows 1/2 for tangent, And then sine is equal to opposite over hypotenuse, so that would be equal to 1 over the square root of 5 or square root of 5 over 5.